Hi guys, so today we're going to start looking at conic sections. So conic sections are going to be what occurs when you see these two cones that we have here on top of each other. If we take that cone and we slice into it, okay, so we slice part of it off, the shape that we have when we slice it off, that's one of our conic sections. Basically, it's what would happen if we took a plane and that plane intersected with a cone. So let's say, for example, here, if I just took a plane right there and sliced into that cone, we're going to look at what shape would occur at that intersection. Okay, so you guys can see here what's in red and outlined in black. That's a shape that occurs if I were to slice my cone that way. And you guys can see it's graphed next to it. That's creating a circle. So if I make that plane parallel to the base of the cone, it's creating a circle. So what we're going to do now is we're going to change it a little bit, and we're going to see if I put that in a different place. All right. So now it's not quite parallel. Okay, it's made an ellipse. Okay, and again, the more we move it, the more that changes. Okay, but there's my ellipse if I slice it at an angle like that. Alright, now let's say I slice it even farther and it keeps going and it cuts through the bottom. Now you guys can see that shape that's outlined in black there. Okay, that shape that we have is a parabola. So if I cut it at an angle and it goes through the base, then it's going to create a parabola. Alright, so I have a parabola there as well. Still have a parabola. And then the last case is if I take this plane and I intersect both cones. So I make it parallel kind of to parallel to that middle axis if I make my line, then slice it this way. That creates what looks like there's one parabola and then there's another parabola. Okay, that actually is going to be called a hyperbola. Okay, so a hyperbola is going to be what occurs. I'm going to move this just a little bit so it's a little easier to graph. Okay, that a hyperbola is what occurs when we basically slice both cones. So that's the shape of a parabola. It's like, or hyperbola. It's like two parabolas basically. Alright, so let this run for a little bit so you guys can see what's happening here. So parabola, and then it becomes an ellipse, and then it becomes a circle. So ellipse, parabola, hyperbola. So those are our four conic sections. Alright, we're going to look at circles, ellipses, parabolas, and hyperbolas. Alright, so what we're going to do to start is we're going to look at circles. Okay, circles actually, this is going to be hopefully a lot of review for you guys because you learned about the equation of a circle in geometry. We're also going to review how to complete the square, which you learned about in Algebra 2. So to start, we're talking about standard form of a circle. That's the equation that's given here. In this standard form, the center of my circle has the coordinates h, k. So notice how both of these are minus. Okay, this is going to be pretty consistent for most of our conic sections. That means if this was x plus 3, then my center would be negative 3. Okay, if this was y minus 7, then, if that was y minus 7, then that coordinate would be a positive 7. And then r is my radius of my circle. So it's the square root of r squared. Alright, so let's look at an example here. This is already written in standard form. So I need to find my center first. So that center is negative 3, 1. Then I'm going to find the radius. So if r squared is 81, then the radius is 9. And then I'm going to go ahead and draw a graph here. So the first thing I'm going to do is I'm going to plot my center. So negative 3, 1. Then from my center, I'm going to move 9 in every direction. So I'm going to plot the 4 easiest points. That would be if I go all the way to the left, which would be over at 12. If I go all the way to the right, sorry, that would be negative 12. If I go all the way to the right, that would be 6. If I go up, I would go up to 10. Sorry. And if I went down, I would go down to negative 8. So that's all moving a distance of 9 away from my center. Connect my dots in the best circle I can. And that's my graph. So in order to graph a circle, all you need is the center and the radius. Now the toughest thing about circles is that sometimes they're not already in standard form. So if they're not in standard form, then we're going to look at a process called completing the square, which you used back in Algebra 2 in order to write this in standard form. So the first thing I'm going to do is I'm going to put my x terms together. So I'm going to rewrite this as x squared minus 10x plus y squared minus 12y. And I'm going to go ahead and move the 45 to the other side. And I forgot to leave a little bit of space here. Because what's going to happen is I'm going to add a number to make this work out the way I want it to work out. Okay, so I need to figure out what number I can add, and I'll do this two different ways. I'm going to add a number to this first blank here, okay, that's going to make this be able to factor into a perfect square. So something like x plus 1 squared, x minus 2 squared, something like that. To figure out what number I'm going to add, I take the b term, okay, in this case is negative 3. I'm going to divide it by 2, which is negative 5, and then I'm going to square it. Negative 5 squared becomes a positive 25. Now remember, we can't change our equation, so if I add it to one side, then I also have to add it to the other side. Alright, same thing. I'm going to figure out for my y's, I'm going to take the b term, the negative 12, divide it by 2, I get negative 6. I square that and I get 36. And if I add it to the left, I have to add it to the right. Okay, so just a reminder when we're completing the square, okay, that process, you take b, you divide it by 2, and you square it. That's the number that you're going to add. So what that sets up now, if I were to factor this, okay, it's going to factor perfectly into x minus 5 squared. And you'll always work out to where this number is going to be basically when you took b and you divided it by 2, the number you got when you divided it by 2. Okay, so I took negative 10 divided by 2, I got negative 5. Look at our y's. This is going to be y minus 6, because again, I take negative 12 and divide it by 2. And then if I look at my right side and simplify that, negative 45 plus 25 is a negative 20, plus 36 is 16. So that's the equation of my circle in standard form. Now it's easy to find my center, my radius, and I can graph this if I wanted to. So this would be a center of 5, 6, and the radius here would be 4. Alright, the last thing we're going to look at with completing the square is just if you have a value larger than 1 as your a. So in that case, I had 1 for a, so it's a little easier. If it's not, we need to consider that and factor it out. So, so let's go ahead and set this up. I'm going to go ahead and take my x's, put them together. Put my y's together. And what I'm going to do this time is I'm going to go ahead and factor out that number in front of my x's. So the 3 is going to get factored out. So I'm left with x squared minus 2x now. And I'm still going to need to add something, so I'm still going to leave a blank there. Then we go to my y's. So I'm going to factor out my 3. I'll be left with y squared plus 16y plus blank, and that's equal to 168. So same process here. I'm going to figure out what I need to add. So I'm going to look at the b. The b here is a negative 2. So I take negative 2, divide that by 2, and get negative 1. Negative 1 squared is a positive 1. And whatever I add to one side, I add to the other. But be careful now. I'm not just adding 1, I'm adding 3 times 1. So I'm going to actually add 3 to the opposite side. Then let's look at my y terms. 16 divided by 2 is 8. 8 squared is 64. So I'm actually going to be adding 64 times 3 to the right side, which gives me 192, which means I have 363 over there. So let's go ahead now and write this in my factored form. So now I have 3 times, I can go ahead and factor that. That becomes x minus 1 squared. This becomes y plus 8 squared. And this is going to equal 363. And And then the last thing I need to do to make this look like my standard form is I got to go ahead and divide everything by 3. Okay, so let's divide everything by 3. That gives me x minus 1 squared plus y plus 8 squared, and that's going to equal 121. So again, now it'd be easy to graph this circle. The center would be 1, negative 8, and my radius would be 11. Alright, the last thing we're going to look at is just how to write domain and range and how to write the equation from a graph. So let's go ahead and write the equation of this graph first. So in order to write the equation, I need the center and the radius. So my center is not given, but I have 2 points on my circle here. Well, that center is going to have the same x-coordinate as the point above it, and it's going to have the same y-coordinate as the point next to it. So the center of this circle is going to be -2, -3. My radius is going to be the distance from my center to any of those endpoints. So if I look at that distance, from -2 to -3, I'm moving a distance of 1 up. I'm moving a distance of 1 side to side. So my radius here is 1. So that would make my equation x plus 2, remember it's the opposite sign, plus y plus 3, and that's equal to 1 squared, which is 1. And last thing is just domain and range. Just a quick review. We're going to write these in interval notation. So my domain is the furthest left this goes. It actually touches the x value of -3. And then it's going to go all the way to the right there. Now that point's not listed, but I know the radius is 1. So I'm going to go a distance of 2 away, which puts it at -1. Range, the furthest to the bottom this graph goes. -2 is the highest. The center's at -3, which means the lowest point would be -4. And the highest there is -2. So that's domain and range.